What if we used trees to light our streets instead of electric street lamps? Imagination and innovation are the forces that have advanced our civilization throughout history. Our generation's frontier is synthetic biology. Our guide, nature itself. And as usual, the potential is limited only by our greatest imagination. So why do we need this when we can use this? Inspired by fireflies and aquatic bioluminescence, our team of Stanford-trained PhDs, Carl Taylor and Omli Drury, are using off-the-shelf methods to create real glowing plants in a do-it-yourself biolab in California.
So first, basically, we find cool genes from the environment, in this case, the glowing genes from bacteria or fireflies. Then we used software like Genome Compiler to rejigger the genes so that the plant itself can read what those genes are. We then go online, have the genes made, and then shipped to us by FedEx or something like that. Then we take those genes, put them into agrobacteria. We can then use the agrobacteria to transform the plant. We can then grow up those plants and get glowing plants. I'm meant to be there, not here. So.
We've designed the DNA sequences, and now we need your help to synthesize the DNA and transform it into a real glowing plant. Back the project today and be one of the first to get a glowing plant. What you'll be getting is more than just a glowing plant. The glowing plant is a symbol of the future, a symbol of sustainability, a symbol to inspire others to create new living things. Help us light the way. Share this video with a friend. Together we can achieve amazing things. Show that you care by backing the Glowing Plant Project today and demonstrating your commitment to a more sustainable future.
Car application where you want to know always like how far can I go on my charge, right? Is my car finished charging?
Logistics, so
we decided today we would just talk as if you weren't there at all about your evil little plants and how they're going to take over the world like gremlins. So talk to us a little bit, because I think there's a lot of misconception out there about what they actually are, and they're basically plant biology's little lab rat, essentially. They're the first plant to have its genome sequenced. So let's talk a little bit about the plant, and then we'll get into some of the other issues.
Yeah, that's what I mean. We chose Arabidopsis precisely for that reason. Yeah. It's the fruit fly of the plant biology world, beloved by scientists because it's got a very short genome. It's been extremely well studied. We know far more about it than any other plant. And it's non-food, it's non-pest, it's non-invasive, and we're introducing non-toxic genes. So we really thought this was about as safe as you could get with this kind of technology.
And I think also I've been hearing some people talk about, the transfer of DNA, and one of the things that you and I had talked about was that, high-level organisms can't transfer DNA. So if you guys eat a hamburger today, you're not going to become part cow tomorrow. So this is they can't transfer those genes back and forth.
And I think that's a widely misunderstood conception about this. Higher level organisms, anything multicellular essentially, doesn't swap DNA.
Yeah.
And so, the chance of that, we put this DNA into a plant, that doesn't mean that suddenly every plant in the forest is going to be glowing. And so, a lot of the scare stories that people have and fears that people have are really not grounded in reality. And I think that's the big problem with genetically modified organisms in general.
Exactly, and I think we want to talk about GMO for a little bit, but the idea that you had one of the most successful Kickstarter campaigns, right? Something like 484,000 in 44 days. I think you raised 7 times your goal, something like that, like 65,000. Everybody was crazy about these plants. Everybody wanted them. And you did rewards for donors with seeds and potentially roses. And then the bottom fell out a little bit in that there were some NGO groups that got sort of worked up. And then Kickstarter sort of quietly changed its policy. So how did that affect you guys? And let's talk about that for a little bit.
Yeah, I mean, we obviously knew that genetics is a controversial topic. So we were not entirely surprised. I think what we were surprised about is quite how this just exploded out the gate. I've definitely learned to become a lot more thick-skinned You know, this is the first time I've been involved in something that blew up on the internet, and you learn that haters out there are just going to hate. But the flip side is that there's a lot of amazing people out there who've really just shown us a lot of love as well, and that's what makes a crowdfunding campaign so rewarding.
Yeah, and I was reading a lot about, there's a lot of like parents that were really excited to be able to get this for their kids and show them science. And so, you know, I think Time magazine did a fantastic piece in August about the real issue that sort of played out here with these two tribes, you know, inside of Kickstarter, the original founders, very artistic and creative, versus the tech community that tends to embrace open source and coding. And so, I mean, how do you feel like for the future? I mean, because in a way, the program's sort of flatlined in that sense, but like Indiegogo didn't make any policy changes at all. And what are your feelings on that?
That's right. I mean, you know, crowdfunding for synthetic biology is certainly not over. You know, there's a live campaign on Indiegogo at the moment to create a yeast, a yogurt that will express resveratrol, which is the molecule that keeps you alive from drinking red wine. Personally, I'd rather drink the red wine. But,
exactly.
you know, some other people maybe not want to do that. So, you know, it's certainly not over. I mean, I think the great pity is that Kickstarter is the leading platform. It gets you a lot more brand recognition, traction. People know what it is a lot more than these other platforms. And unfortunately, the founders handed a bit, you know, we're in a propaganda war between the technologists who want to see this technology, who believe in synthetic biology. It's an incredibly powerful technology. It's the fundamental costs of doing this are falling 3 to 7 times faster than Moore's law.
Genome sequencing has come down dramatically.
Right.
I mean, it's the fastest tumbling cost of technology in a very long time.
In human history. Nothing in human history has fallen in price as fast as the cost of reading DNA. And all of us are DNA. It's a profound shift because, you know, our food, our energy, medicine, our very nature is DNA. And we are at this amazing point in history where we're beginning to understand this tool, and we're beginning to develop applications with that. And I think that crowdfunding offers an opportunity for us, the people, everyone in the world, to be a part of this and to control this and to not have it be dominated by these big, large institutions and corporations, which, let's face it, have shown themselves again and again to not be trustworthy with this.
It's true, and yet the irony is that one of the issues of some of the people that were against it was like, we want to stop any of this, the corporations are bad, but in fact, if we don't stay active in a way through these crowdfunding campaigns, then they sort of win in a way. So I like the idea that we talked about around coders and hackers, you know, used to have to live in dark corners in our world. And now they're sort of the seed of innovation for us. So, you know, why would we not want biohackers? I mean, the things that they could make, what do you think about that?
I mean, I don't really like the term biohacker because when it gets out in the mass media, people still have a negative, you know, people in tech think of hackers as a good thing, but the rest of the world is still not quite sure about it. But, you know, I think that's what we did this project for. We wanted to create a signature project that would inspire people about the potential of this and wake people up all over the world to what can be done in a small lab. You know, we do our work in a converted shipping container. And it's amazing to me that we can do this really advanced genetic engineering in a shipping container.
Car? What do you mean a shipping container? Came off a boat? By the docks?
Yeah, it's a shipping container. It's parked by the docks in the dog patch in San Francisco.
Okay.
Yeah. And it's amazing. And I think...
Sounds dodgy, doesn't it?
I mean, I'm sure the FBI would wonder whether it's being used as a meth lab, but...
This reminds me, where is the plant? Why do we not have a plant here?
So the plant is glowing.
Okay.
I'm, you know, really pleased to say that. It's, we haven't done all of our work yet. We've put 2 of the 6 genes.
But it is glowing.
It is glowing. Okay. You can see it when you're in our lab. But of course, we couldn't bring it to the European Union. The EU has some very stringent regulations. The most difficult for us being the fact that you have to monitor every plant that's out there. And that's obviously completely economically infeasible. And change of that is going to be hard because there's this big gap in the public perception between what people think about these technologies and actually what the science says.
Well, this is the thing. If you, my headpiece is coming off here. If you think about it, no matter how much science says one thing, if you have a preconceived notion, it doesn't matter. You're not going to sort of deviate from that. So Why are people so upset about GMO? Let's talk about that for a little bit, because there's a lot of good applications in terms of feeding the world with the populations exploding. So you want to talk about that, or is that too...
No, I think it's an important question, and I think it's because of trust, fundamentally.
What do you mean?
I think the first organizations to introduce these products, people like Monsanto, didn't do it in a very trustworthy manner, and I think they kind of lost it for the industry. They're doing things like suing their customers. And so people don't trust these organizations, and because it's something that you can't see, and it's very hard to feel, once you've lost trust, it's very hard to regain it.
That's part of the issue of the ETC group, too. They were like, we have to monitor this because they're evil, and it's all going to come down bad on humanity.
Yeah, I mean, we have a very different philosophy. We look at the amazing creativity that's come out of the internet industry, and what happens when you distribute technology, when you make that technology available to a really broad number of people, so that teenagers and people in high school can actually do things with it. And we believe firmly that when you do that, then the world can hold these other groups accountable. And to do that, then we need a system where everyone has access to this, and that's that's why we release our stuff open source.
And I think you have to start somewhere. I mean, this idea of this is a future tech conference, right? We've seen a lot of science, a lot of robotics, a lot of AI outside of web-based type things. So, I mean, when is science really going to get out of the closet? Because when it does come out, sometimes it gets like beat back in again. This is a good example. So, I mean, DNA sequencing isn't new. It's not like it's a brand new thing, and we are talking about a very low-level organism. But what are going to be the implications for maybe DNA sequencing when it comes to humans? I mean, that feels like something a little more important.
And I think this is where we need to push the discussion. Yeah. Absolutely. I think GMOs, there's so many studies out there, there's big meta-studies saying that really these are safe and that the benefits outweigh it. But we do need to realize where this is going. And at some stage in the next 2 or 3 decades, it's going to cost $1,000 to synthesize a human DNA sequence. That's the 6 billion base pairs. It's already $1,000 to read that, and the cost of synthesizing it is a few years behind. That obviously enables designer babies, all kinds of crazy, difficult, ethical, moral, social questions that are really important for us to decide as a human species where we want this to go. And we can't just allow this to be pushed into the black market, and we need to have this debate out in the open.
I think that is a danger of it moving into the black market. We did have a brief discussion with Brad Templeton last night about the whole designer baby issue. Right. But and when you ask people, though, if you ask them if you could change and get out disease and not have those things, would you do it? But if it comes to vanity, people are completely against it. So how is it that this tiny plant weed has become such a monster to everybody?
I mean, I don't think it has become a monster to everybody. I think that's absolutely not true. I think what we've done is we've revealed a sort of fundamental split. And I think if you look at sort of the general population, I would say 30% are very in favor, 30% are very against, and about 40% in the middle haven't really made up their mind yet. And so and I think that's why there was so much energy around our project. We sort of ignited these 2 different groups. And you look at the Reddit discussions in the future tech space, and they're loving it. So I think it's important to not just get overwhelmed by the naysayers. Our target market is the other group, right? Yeah. Really. So
that is what they want. I mean, but also it keeps discussion alive. I mean, in a way, it just prompted more articles to be written and more people to discuss it. So which, if
you're running a Kickstarter campaign, is really good.
It's a really good thing, right? So, I mean, in a way, it worked for them. But in terms of the plants, so when are they going to be? When are you going to be shipping them out?
We're going to be shipping the seeds in next summer. So we still think we're on track for on-time delivery. Good. Sometime towards the end of May, the first batch will go out. And
I wonder if we could. I mean, I can peek into the room and see. How many people? Did anybody order glowing plants? Anybody? I'm looking. Not one person?
We're in Europe, so it's
tricky. We're in Europe. There were some Americans out there. I saw them last night. Okay. Would you order a glowing plant? Many hands. Because you can't order them because you're in Europe, right?
I guess who wouldn't is also the question.
Who wouldn't order a glowing plant?
1, 2.
3, 4, 5.
But so this is our target audience.
Yeah.
So.
Okay, so that's interesting. And so.
I think one of the things that we need to recognize with this as well is that things like the European regulations have a very negative impact around a lot of the world. And it's all very well for sort of politicians and activists sitting in Europe who are well-fed and have good food.
Okay, let's get to that.
Yeah, so it's all very well for them to sit there and sort of say, we're not sure about these risks. But we have to remember that for every action, there's also the cost of not doing the inaction.
Exactly.
And if we look at the developing world, that's where this cost is really being borne. It's really being borne by people, bananas is a fantastic example that's starting to get a little bit of publicity. Bananas are clonal, which means that every banana that you eat has the same genetic identity as every other banana. And as a result, it's susceptible to certain diseases. And there's a particular fungus that's threatening the entire global banana supply. And as a result, they're spraying them with all these toxic chemicals, which feed into the water supply in the villages that people are growing up around these plantations. Now, there are other banana strains that are resistant to this. It would be very easy for us to insert a DNA and create a banana that just didn't need the spraying in the same way. And yet, because of EU restrictions, we can't do that.
Right, and yet then people are poisoned by the chemicals that are going in to stop this disease. So, that's like a trade-off, right? Where's the trade-off? How do you justify one over? How do you justify chemicals and pesticides over putting a DNA in a banana that's going to make it resistant to disease?
In my mind, there's not a lot of trade-off.
Right.
I think we create a better product that means that we don't have to spray it, and that's good for everyone. It's better for the environment, and it's good
there
for
was that
people
Italian study that came out recently that talked about there's no transfer. It doesn't matter what you put in there. There's going to be no transfer of that. So, over time, there are plants that develop a resistant to pesticides over time. That's evolution, one would say. But, the repercussions of all the toxicity in the soil for people around you is really very high.
Right. Yeah, so I'm obviously a strong believer in this stuff. I just think we need to have a bit more of an informed debate. What we would like to see come out of this project is an emergence of a new ecosystem around applications like this. So,
For example?
Just as we sort of, I think the great power of Kickstarter, if you look at what it's done with hardware startups, it's really created this whole new industry around being able to take these products to market from a startup perspective. And we'd really like to sort of see that happening with biology as well, that the applications are so fundamental to who we are. Everyone's out there building social, mobile, local apps. Why not go out there and build things that really positively impact human lives?
Why don't they? Why don't we?
It's still early days for this industry, and it's still a controversial topic. But I think we can shift the debate a little bit and get people out there. In 5 years' time, it's going to be as easy to build a biology app as it is to build a mobile app today, and that should unleash huge amounts of creativity. And lots of opportunity for people to get in there early.
And how many people in this room actually would build something like that if you could? Wow.
A few.
Bravo.
Yeah. Well, come to our lab in San Francisco.
Come to the train car in San Francisco. It's like an X-Files episode, doesn't it?
Yeah.
What about GMO labeling?
Yeah, that's another. It's obviously popping up the political agenda in the US at the moment. There's a ballot initiative in Washington State. At the end of the day, consumers have a right to know what's in the food they're eating, and we should be allowed to choose with the market. I think food labeling is a really good thing.
But do they put what crops have been which pesticides that apple was
Maybe they should
sprayed
put
with?
that too.
Maybe they should. And I was reading somewhere a very good salient point around labeling. That was this person was against it because he said this would just give credence to things that we don't even know. It would put fear in things that we don't even understand yet. So, if you're going to have GMO labeling, maybe you should say this apple was sprayed with XYZ at the same time.
But I'm not sure what the concern is with GMO food. Americans have been eating it for 10 years, and I'm not aware of a single case where someone's got sick or there's been any kind of negative implication from eating that food. I think the science the science is absolutely robust
Yeah.
that on a safety level. It's the second and third order implications that cause more controversy.
And also the political agendas, I think,
Right.
tend to come into play.
Right.
Okay.
And large corporations.
Should we open them up to questions, or is that going to be too risky?
Sure.
Do you guys, oh my God, we have like 18 seconds. Quick, who's going to go quick? Who's going to jump up? Nobody. Nope, somebody wants to. No. Okay. Well,
Well,
good
thank you,
chat.
Jennifer.
Thank you. We're done.